In this class, we are discussing about circular motion. Motion of a particle along the circumference of a circle is called circular motion. So here is a particle and it is moving along the circumference. If the particle is moving along the circumference of a circle is known as circular motion. And we have some examples here. Earth revolves around the sun in a circular path and it is moving along the circumference of the circle, so it is known as circular motion. Another example, satellite is revolving around a planet or earth. It is moving along the circumference of the circle, so it is in the circular motion. And the electrons are revolving around the nucleus, and the particle or electron is moving or describing around the circumference of the circle, so it is in circular motion. And here the fan rotates by itself, so it is not known as a circular motion. But if you take a point here and if you see the point, it always moving around the circumference of the circle, so the point will be in the motion of the circumference toward means along the circumference of the circle, so it is said to be circular motion for the particular point in the blade of a fan. So you should not confuse between the circular motion and the rotational motion. Okay, fine. Now we have some characteristics of circular motion. Here you can see, here is a circle and here is a point P, and we can say the point P as a particle, you can assume as a particle, and this is a center. And from if you draw a line from a center to the particle is known as a radius vector. It is called a radius vector. Another name of radius vector is called position vector. Position vector. Now if you want to find a direction of the particle at any instant, you have to draw a tangent. So this line is known as instantaneous speed or a tangential speed. It is known as V. And this V always constant for the uniform circular motion. So the magnitude of the speed is constant but the direction changes continuously. Suppose the particle is in this point 1 and number point 2 and number point 3. So you have to draw a tangent along the circumference of the circle. So you can see the direction changes, number 1, number 2, number 3. Position changes but the magnitude doesn't change because the uniform circular motion. But what happens, the direction changes continuously. Since the direction changes and it is said to be acceleration, because for the acceleration speed the magnitude is constant. Magnitude means the speed of a particle is constant but the direction of a particle changes continuously, so it is said to be acceleration, right? And here you know the characteristics, the particle always moving along the circumference of the circle, and it is the translational motion but in the curved path. Translation motion in the curved path. And this position, a line drawn from the center to the position of a particle is known as a position vector or the radius vector, and the direction of this position vector is always outward. It is going out from the point, from the center to the particle. And here the velocity, the magnitude is constant because the motion is said to be uniform. If the motion is non-uniform, then the magnitude and the direction both will change. Here instantaneous velocity. Now here is a circle and you take any point P. At this particular instant, if you want to find velocity, you have to draw a tangent. So this will give you magnitude. Of magnitude means the speed of the particle which is moving around the circular path. So this instantaneous velocity, otherwise called tangential velocity. Tangential velocity. For the uniform circular motion, the tangential velocity magnitude is constant. Magnitude is constant, but the direction changes continuously. Direction changes continuously. For the non-uniform motion, both magnitude and direction changes continuously. So here is the center, a line drawn, from the center point O to the particle P is known as a radius vector or the position vector, and tangent drawn along the circumference of the circle is known as instantaneous velocity or the tangential velocity. Always it makes 90 degree to the position vector or the radius vector. It is always 90 degree. And here the radius vector always acting away, that is called radially outward. As the particle is moving around the circular path, we need a force to maintain the particle move in a circular path. The force is called centripetal force. Centripetal force. And according to Newton's second law, we know the force is directly proportional to the acceleration. So as the particle is moving at a constant speed, here it is in the uniform circular motion, so there will be a constant centripetal force needed to be acted, otherwise the particle will not move in a circular path. So any object which is moving in a circular path, the centripetal force is important. If there is no centripetal force and there is no object move in a circular path, as the centripetal force is acting here, there will be acceleration is known as centripetal acceleration. Centripetal acceleration. And the centripetal acceleration, the direction is towards the center. Centripetal force and centripetal acceleration, the direction is towards the center. So which is the opposite direction to the radius vector. Radius vector radially outward and centripetal force acting towards the center. So now one example. Here is a stone. We are whirling the stone using a string and it is moving around the circumference, and you are increasing the centripetal force gradually, so the speed of the tangential velocity increases. And as you are increasing the centripetal force more and more, which means we are increasing the, technically I say we are increasing the tension. So the tension is directly related to the centripetal force. As we are increasing the centripetal force, which means the tension of the spring, so the string increases. So the as you are increasing tension more and more and more, at a particular time the string will happen to break. So what happened? The stone will fly off in a tangent direction, in a straight line. tangentially in a straight line. If the stone is here, if the string breaks at this point, then you draw the tangent. This is the direction of the stone will fly off in this direction. The normal, here is the axis of rotation. If you draw a normal to the plane of the circular path and it rotates in the counterclockwise, this line drawn to the perpendicular to the plane of the circular path is known as axis of rotation. And here the uniform circular motion, we have some characteristics. The characteristics are the magnitude is constant. What is magnitude? The speed. The speed of the particle is constant, but the direction changes. As the direction changes continuously and the particle is said to be accelerated. So there is an acceleration. And here to make an object accelerate, we need a force, right? And the force here, as the object is moving, the particle is moving in a circular path, and the force needed is said to be centripetal force is needed. Centripetal force is required, a constant centripetal force is required for uniform circular motion. So you increase the centripetal force and to increase the tangential velocity or instantaneous velocity. And another one, it is a periodic motion with a definite period and frequency. Here we have the period and we have the frequency. In the uniform circular motion, what is period? The time taken for one complete circle. An example, time taken for the period of earth to revolve around the sun is 365 days. The same, a period of rotation of electron around the nucleus, which means to rotate, to revolve around the circular path, it will take a time for one complete revolution. For one complete revolution, the time taken for one complete revolution is called the period. And frequency, number of revolution in 1 second, that is frequency. So it is a periodic motion with a definite period and frequency. In uniform circular motion, magnitude of centripetal force acting on the body is constant. So as I mentioned here, it is constant. And another in here, the angular speed and the radial acceleration and kinetic energy, momentum, everything is here constant. What are the things here? What are things are constant? Linear speed, centripetal force and centripetal acceleration, momentum, kinetic energy, all these quantities are constant. Another important thing is the angular acceleration and tangential acceleration is zero. Angular and tangential acceleration is zero in the uniform circular motion. So these are all the points or the basic information for the circular motion. In the next topic, we will discuss about angular displacement, angular velocity, and angular acceleration. Thank you very much.